On this one, we're going to look at several things related to revenue and profit and how to go about finding the maximization for the revenue and profit here. It says that a company manufactures and sells X smartphones per week. The weekly price, demand, and cost equations are given here. P equals 800 minus 0.3x and C of x equals 30,000 plus 100x. We start off with the first part that says, what price should the company charge for the phones in order to maximize revenue? How many phones should be produced to maximize the weekly revenue? What is the maximum weekly revenue? How many phones should be produced to realize the maximum weekly profit? And how much should the company charge for the phones for maximum weekly profit? And then finally, the last one is, what is the maximum weekly profit? Okay, so the idea again with maximization here or minimization, like in the last one, it's all going to come back to derivatives and solving the derivative equal to 0. Let's start with the first part here where it says, what price should the company charge in order to maximize revenue? Well, revenue, which is often written as R of X, is equal to taking X, which is the number of units sold, times the price, P. Well, we have P up above is equal to 800 minus 0.3X. So we're going to start there by multiplying X times whatever P is equal to get revenue. Distributing this here tells us that R of X is equal to 800X minus 0.3X squared. Now we need to order to maximize revenue here. To do that, we're going to need to find and solve R prime of X equal to 0. So R prime of X is equal to 800 minus 0.6X. And so what we need to do is then set that equal to 0 and solve for X. So in this case, we'll need to subtract over the 800 and get negative 0.6x is equal to negative 800. Then we'll divide out the negative 0.6 to both sides. And this x will then solve for the number that will maximize profit. Rounded to the nearest whole number, that was 1,333. That's the number that they have to sell. To determine what price they need to put it at in order to sell that many phones, we'll use our price function for P equals 800 minus 0.3x. So we'll just sub in the number for x, 800, minus 0.3 times 1,333. The price in this case, rounded to the nearest tenth, is $400.10. Now the next question on part B was asking us how many should be made in order to maximize revenue. Well, we actually already asked that question or answered that question on the last part. That's where we solve for x to get 1,333 to maximize revenue. And then on part C, it asks, what is the revenue? We can get that by plugging in our number for x here, the 1,333, into the revenue function. So we go back to the revenue function and we plug in the number for x and see what we get from there. It's going to be a pretty big number because there's a lot of revenue here for this product. It comes out to be $533,333.30. Now the next one asks, what's the price in order to maximize the profit? For this, we need to create the profit function P of x, which we create by taking the revenue minus the cost. Our revenue function we found a little bit ago was 800x minus 0.3x squared. Our cost function is 30,000 plus 100x, and so we're going to subtract all of that with the revenue. What that's going to look like when we simplify it down here, it's going to look like negative 0.3x squared plus 700x minus 30,000. Now what we need to do is find the derivative and set it equal to 0 and solve. So the derivative here, p prime, is going to be equal to negative 0.6x plus 700. And if we set that equal to 0 and solve for x, it's going to be the same routine that we did before. Subtract over the 700, divide by negative 0.6 to both sides. What we're going to get here when rounded off to the nearest whole number is 1,167. That's basically, again, the number of units that's sold in order to maximize profit. So that's phones here. And that's the answer to this part here that asks specifically how many should be produced to realize maximum weekly profit. And then the next part here is price. How do we find the price for maximum profit? The price, P, will be equal to, again, plugging in the number for X into the original P equals formula, which gives us a number here of $449.90. Then to calculate the actual profit based off of this, we'll go back and plug in our number for X into the original profit function. And so our profit function from up above with this number for X is going to look something like this. That comes out to $378,333.30.